vertical line? The most vertical line you need to fill out the line.
Let's do this.
Number.
Actually, get 100 on the next test.
You guys the left. Use the box and two. You can say. Vertical line and a horizontal line. And then some right.
So I need you to get a graphing paper for this notes. And you need to try to draw
I got
the
it.
best notes for this part. Because we're going to go through a lot of parent function. We're going to talk about transformations at the same time.
And piecewise functions. Oh, yeah. I want to knock the thing down. Sorry.
Wait, what? Oh, that's so, look at this. There you go, cross. 1, 2, 3, 8 morning, and then took her like 2 seconds.
What?
She just made a cross on 22. She made a cross. The thing just lies side by side.
That makes no sense.
That makes perfect sense.
I was confused too, but then it makes sense. But the ball lands on the line.
Wow. I'm sorry. Too much. Too much pain.
Alright, so put your computer away. Lenny, put your computer away. So we're going to talk about transformations. Computer away. Hey, do that after class. Stop copying. Do your own thing. Jeez. Do your own thing. So we're going to talk about all the parent function. And the parent function, we're going to start with all the one here. So we're going to talk about all those. So what are the parent functions that we're going to talk about here? The first one is y equal to x. Y equal to x is one of the things that we've been doing for a while. If I were to do a t-chart, that means I plug in x and y. If I plug in -2, what am I going to get? -2. -1, -1, 0, 0, 1, 1, 2, 2, right? So basically it's going to form those points. So I'm going to go through really fast. And the line is going to keep on going. And this is an easy one. But we're going to talk about a lot of things on this function. Okay, so then we're going to talk about domain also. Michael, we can be the way. You can do that next period. Negative infinity to infinity, because if I would do a vertical line test, not vertical line test, domain, if I domain here, this line is continuous going this way, right? So I will have all real number throughout across, because the line is always going to be intersecting here. Does that make sense? So I'm going to have touching all the points. Domain range is going to be negative infinity, positive infinity. Okay? But this one's easy. Nicholas, you better want to copy down. You got a graphing paper, copy down, because those are important, because I cannot tell you what a parent graph is. Now, I built this table, you also need to copy down, because that's going to help you here. Now, we're going to talk about next thing is it might not be something you know. Is this even or odd functions? Nicole, you want to change your C so the iPad doesn't block you. You can change to next to Jaden. Is this an even or odd function? Now, how can you tell it's even or odd function? So I'm going to tell you, even or odd function is very simple. It's just like your face, okay? Your face right here, it should have a symmetry. Your eyes are this high, and this eye is this high. So this is called even, okay? Your face is even, that means they have symmetry around y-axis. Okay, put your computer away, put the computer down. Okay, so this one is not an even function because if I do it here, do you see the symmetry? No. But you do see the symmetry based on this point, however. So this is called symmetry to origin. So symmetry to origin. And we're going to talk about that, symmetry to origin. Okay, symmetry to origin. If symmetry to origin is called odd functions. And how can you tell that? It's an odd function. You go to the same value but the opposite one. From -2 go to 2, right? Look at the y value. The y value is exactly opposite compared to this. So this one, the y value is what? Opposite. -2, positive. -1, positive 1. So that's called symmetry to origin because it's all the way to the other side. If you think about this, is -1, 1, and this one's here. Okay? So therefore, this is an odd function. Odd function is symmetry to this point. And it's always the same distance to that point. If you see that, same distance, same distance. Next point, same distance, same distance. Same thing, so that's odd function. Okay, so this is an easy function. You should know. Lenny, put your computer away. It's okay, you can do it next period.
We're the gym.
So, go to the next one. Y equal to x squared. Now this is an equation make a lot of money, believe it or not. 10 years ago when iPhone come out, the first game that ever come out of iPhone is what?
White?
It was black.
Oh yeah, black.
Ping pong game.
The ping pong game. No, actually the first most popular game.
Oh, games.
Angry Birds.
Yeah, Angry Birds.
Okay, Angry Bird when they first come out, they make the parabola equation and they make $300 million in the first 5 years.
On that?
On this graph. This is called parabola graph.
Oh yeah.
A parabola, remember there was a thing and they can shoot things like this. Those are parabola equation. Then they make this, they're banking on this. They're making $300 million the first 5 years. Is that crazy, Sam? Yeah, that's pretty crazy. $300 million. And now they are like a multi-billion-dollar business, I think, because they sell shirts, they sell toys, they sell everything.
Yeah.
Movies.
Yeah.
Jesus, they are in a whole franchise by itself.
That was the equation.
Just from this equation. It's ridiculous, Sam. Now that the equation is not complicated, like Star Wars, Angry Bird, they actually going around. They go in like based on gravity. You can shoot somebody like backwards. So they're based on the very core function. They actually based on the force equations.
I love how you know this stuff.
Huh?
I love how you know about the Star Wars, Angry Birds, and stuff like that.
Oh, I played it. So I don't know about you guys. I like games. I haven't played Fortnite yet. But
It's not worth it.
What cost it?
No, it's worth it to us.
okay, so if I were to plug in the same point, right? If I plug in -2 here, it's gonna square this, so it's gonna be what? 4 or -4?
-4.
4. It's 4.
What?
Because remember, it's
Squaring.
-2 squared.
Oh, that's why. Kind of wondering.
So now it's gonna be 1, and that's 0, this is 1, this is 4. So now this is a parabola equation, so we call it parabola. And then we say look like U. Look like a U. So not only that, so it's gonna be based on this point and this particular point. And the graph's gonna be like this. Okay, so that's a U shape. And then you say, okay, what is that? Domain is what? Perfect. But range, be careful though. It's look this way is the domain, right? This is all intersect because the line's gonna go here. It's intersect the whole way. So therefore, it's all real number, but range, look at which way?
The other way.
Down to.
Down, up, right? So go from this direction, look at the shadow of this ruler. It didn't really interact the graph until what? 0. But is that including 0?
0 through infinity.
So that's how you tell range. Next question. You guys gonna raise your hand on this question.
Okay.
Is this even function or odd function?
Even. Wait, what? Even. Odd or even?
Whoever says odd, raise your hand.
Wait.
Is this even or odd function? Odd?
Even.
Odd?
Yeah, odd.
1, 2, okay. How about even? Yes. Okay, so now this is an even function because they are like your face. Look at your chin. Chin's right here.
Upwards.
And that's your ears, and this may be your cheekbones, and this may be your eyes right here. So you can see that symmetry. So this is even. You know, those people are beautiful. They're all even, like Nick.
Hey.
Yeah. So it's even, right? It's even. Y'all just jealous that he's on the thumbnail that you're not. What's your language? Shh. Chris, what's your language? You're on a live stream. Okay, so 0 to infinity, right? Then you're gonna go into domain range. That's even functions because it's like your face. It's left symmetry to right. So symmetry to y-axis. Is the door locked? No. Yes, there's actually. Okay, so symmetry to y-axis. Okay, symmetry to y-axis. Questions? Now, symmetry to y-axis. Now, what else we need to know? There is a point right here. If this is your face, this must be what?
Your chin.
Chin. Your chin's right here. If you look at a person's chin, if you're gonna punch somebody, you're looking for the chin, because chin's not gonna move anywhere, right? Because if you punch it toward the chin, that's gonna hit the face. So that chin is really the very important part. So that is the part that's called, at this point, it's called a vertex. A vertex usually is a minimum or maximum, and it's going to decreasing and increasing. So the function is decreasing here, and stop, and then increasing. So the point that's decreasing, increasing is called a minimum. At this point, it's called a vertex, which is lowest point or the highest point. When you're shooting an Angry Bird equation, something like this, your vertex is going to be right here. Okay? So later on, we're going to talk about those. Now also, that there is an axis symmetry. This is called axis of symmetry. That means x is equal to 0. That's the symmetry. Symmetry between two sides. See that ruler? It's going to represent that symmetry lines. Does that make sense? So that's an even function. Am I going too fast? No? Okay, so you gotta remember this coordinate. This coordinate is gonna come back in play because later I'm gonna ask you to graph exactly. Can I erase? Can I go down? Yeah. So we finished what? We finished y equal to x. We finished y equal to x squared. The next one is absolute value of x. This is the third parent function. So all those are parent function graph. So parent functions here. So we're going to talk about y equal to absolute value of x. We're going to do a t-chart again. What is my value? Same thing. But what do you think the value here? 2. What do you think absolute value of -1? 0, 1, and 2. This really looks like a previous graph, but there's a slight difference. What are the major differences? What do you think this shape look like? A B, good. Because it has an angle now. If you look at it, it's gonna be an angle. So the first 3 points is almost identical. But the next point is really create a difference. So this one is actually a V shape. So look like a B. That's not U, it's B. And what is my domain?
Negative infinity to positive infinity.
Negative infinity to positive infinity. Your range,
0 to positive infinity.
bracket,
Oof.
right? Even on R functions?
Even.
Even, because it's like your face. Some people have pointy chins, triangle face, right? So that's even function
Okay.
because symmetry to what? What is symmetry? To y axis,
Okay.
right?
I see.
It's a vertex.
See.
Vertex is what?
0.
0, 0.
Oh, bukan.
How do you say? How do you say chin Spanish?
Chin,
Just point it.
Barbilla.
Can you
Barbilla.
Barbilla.
No, Barbilla.
¿Qué significa FM?
¿Qué significa qué?
say it, mister.
How to say chin?
Barbilla.
Babia,
Primo.
babia,
Barbilla.
balabia,
Barbilla.
Barjija. I didn't say right.
yeah,
How do you say that?
That's
barbia, barbia.
Y even
Boca.
número primero.
It's Russian.
Nariz.
Nariz, nariz,
Nariz. Nariz.
It's like Nari, say with an accent.
That's how you say it.
nariz.
I'm not paying attention.
Okay. Okay, so I'm learning new words. Okay, so vertex. Now this function, I would like to introduce you definition of absolute value. This is definition of absolute value. So this one is on the side. This is for next year or the year after of absolute value. Okay, so it's actually as a absolute value of x is a piecewise function. So look, I'm going to write it in terms of piecewise function. A piecewise function is this side has x when x is greater than 0. Does that make sense? If I look at this side, if I just close this part off and just look at this part, is x, right?
Yeah.
And this one's going to be negative x. Okay, so that's a piecewise function. Later on we're going to get to that because we might shift that and you can see that better. So that's the definition of absolute value. So even function vertex 0, 0, da, 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 da. Can I go on the next one?
Yeah.
Espérate, right? I'm going to say wait.
Espérate.
Espérate. Espérate. Okay. If you need it, just go back to the video to watch it, okay? So we just talked about y equal to x, y equal to x squared, y equal to absolute value of x. So we're going to talk about the next one. Y equal to square root of x. Square root of x. So you got make sure you put those points on the graphing paper. Make sure you do it well because later on you're going to use that. So square root of x. If I were to do a t chart here, so square root of x. So we're going to say y equal to square root of x. What is it? Well, let's talk about, let's plug in negative numbers, see what happens. Square root of negative 1 is what? I. But I is not on the graph because this is a Cartesian coordinate. It's not a complex plane. We're going to talk about complex plane later. But the negative 1 is going to be I, so we're going to call it undefined right now because we cannot square root of negative number and get a real number. We're going to get a imaginary number, so we're going to say undefined right now. Can we plug in zeros?
Yeah. Yeah, 0.
Put in 0, it's going to be 0.
Yeah.
Putting 1 is what? 2 is what?
1.1, no, 1.414.
Square root of 2, good. Square root of 2 is equal to 1.414. That's a good number to memorize. Yes, that's a good number to memorize. The reason why is on the old SAT, on the now on the new SAT. New SAT doesn't really test this often, but the old SAT test, the square root of 2. They actually have a whole documentary and Discovery Channel talk about square root 2. I had no life one day. I should sit there and watch for 2 hours. And it was actually very interesting for me because it's actually talk about mathematics.
So why is the square root of 2 1.4?
That's a good question. We're going to talk about that. You can watch a documentary. I'll send you the link. I'm pretty sure. I actually have no life. I just sit there and watch it.
Keep it on, Emoto.
Yeah, sure. Square root of 3. So square root of 3 is actually 1.7.
I even know that.
Square root of 4 is what? 2. So you're basically going to build this point. 0, 0, 1, 1, 2, square root of 1.4 is right here, about roughly 1.4-ish. 1.7, and then
What's the square root of -2?
it's defined for now. Okay, so I have a name for this one. This one looks like a football. Actually, it looks like a quarter of football, not exactly all football. So it's actually called I call it a quarter of football. I have a name for this, football. And the reason why I call it football, because in calculus, next year or 2 years down the road, you're gonna take calculus, is imagine I have this curve, and if I build a wire like this, and I have a stick right here, and I take the stick, I spin it, what will happen?
Grind it.
This graph will come out of things, and it's gonna go back, and it's gonna go inside the curve, inside the board, and come back out. It looks like a half a football. And that's how you find the volume of a football. There's no geometry way to find the volume of football except using calculus. You take in that board, that line, and you rotate it across the x-axis and go inside and come back outside. So that's why I call it quarter of football, because that's why I want students to memorize that, because that looks like a top part. If you look at this stream on the top, it looks like that's the top part of football. There's a domain in this functions. What is the domain in this functions?
0 to that 1 point.
Perfect. What about range?
0 to 1 point. No. Well, yeah.
Now there's no vertex here because there's no go up and down. Hold on. It's an even or odd function?
Odd.
Odd.
For now.
Even.
Odd.
I mean, it's
Oh wait, no, it's odd. It's odd.
odd.
It's odd.
Okay, so here's the thing. This is definitely not even, right? Your face is not gonna be just half a face. You're not gonna be beautiful just a half a face, right? Yeah, that's true. Unless you are lady, half is gonna be beautiful. Next time you're gonna take the thumbnail half of your face.
Yeah, you took my face out.
See? So half your face, right? Next time your video is gonna be half, cut off half. Okay, so that is not an even functions, but it's not an odd function either. Do you see that usually odd function has symmetry? Then you should have this point right here if it's odd. You should have a symmetry to origin. You should have a symmetry to origin, but it doesn't. So it's not even and odd, so it's neither even or odd. So it's neither even or odd. It's not a symmetry from both sides, so it's not even or odd. And you say, okay, I can get that. Are we okay so far?
Well, I think
Okay. So it's not odd because there's no point on the opposite of the origin.
Oh, okay.
Okay, there is no the opposite points. If no opposite point, it's not odd either. So neither even or odd, and not there is no vertex, but we're gonna call this point, but it's not mathematical term. It's actually from this mathematic blog, a website called She Love Math, and she's a math teacher that she teaches Precalculus very well, better than me, for sure. So it's 0, 0. She called it anchor point 0, 0. This is the point's anchor point. Now, why did she call it anchor point? Because that's the point you do in transformations. You move up, down, left, right, and all that. Okay. Question about this part? Now, next one we're gonna talk about, how much time I have?
On here, it's been 25 minutes, so.
20 minutes, good. I'm gonna talk about 2 more graphs.
24.
What
Okay.
time is it now?
16 minutes.
Oh, sorry, you have 18. No, my watch says 18. You won't complain?
Okay, so 1 over x graph. This is the 1 over x graph. This is my favorite graph. Okay. One day, I was talking to Ding Cox, and Ding Cox was like, I was like trying to switch some kid into my class, and he was saying, oh yeah, there was like a cult.
A cult?
A cult for people like go to ES class. There's like a cult that believe in ES. So literally, like he says a cult. I say, yeah, not only the cult, I have a sign of a gang. I have a gang sign in this classroom. Okay, so the gang sign looks like one L, looks like this, and there's another L looks like this. Okay, so if you go in now point like this, they know which teacher you come from. Everybody in the school knows this gang sign.
Oh, you put your pinky out too?
No, not L, there's 2 L's.
Oh,
So
thank you.
2 L here is 1 on top of the other. So this is a 1 over x graph.
Like this? Like this? Like your cross?
So 1 over x graph.
No. Okay.
Yeah. They know, everybody knows. If you point like this, and if they do like this, they know, they're from Yale. Okay? So in any math student that's been through me, they know this sign. This is called reciprocal functions. This is called reciprocal functions. Don't join gang. You can join my gang, but you can join other gang. No blood, no crud, no.
No red scorpions, no anything.
Okay, so we're gonna call this gang called reciprocal gang. It's actually reciprocal functions. Okay, reciprocal functions. Okay, so reciprocal function is this one, and you say, okay, what else? Well, I'm gonna plug in a long teacher on this case, very long. I'm gonna start with a -3. And what happened with 1 over -3? It's roughly like close to 0.33 infinite repeating decimals.
You had to put in a decimal.
And if I plug in -2, what will happen? 1 over -2, that's equal to what? -0.5, right? If I plug in -1, what will happen?
The -0.
-1.
Jesus, man, you thought too hard about that.
Oh, wait, it's gonna be undefined then.
If I were to plug in 1/2 negative, what am I gonna get?
Undefined.
No.
What?
It's 1 over 1/2, right? Negative.
What am I looking at?
That's equal to 1 divided by -1/2.
Oh, yeah, I was looking at
That's
it.
equal to 1 times
2.
2 over -1. That's equal to -2.
Jesus.
So what do you think about 1 over 3 is without doing all the work?
You multiply.
-3.
-3, thank you. Because just keep flip change.
Alright.
Okay, now if I plug in 0, what will happen?
1.
Undefined, thank you.
man.
You cannot do divided by 0, it's called undefined. Now I'm gonna do 1 over 3. 1 over 3 is what?
3.
3, good. 1 over 2?
2.
1? 1, good. How about put 2? 1/2, 3, 1/3, right? Now, domain and range of this one's kind of difficult. What is domain in this case?
Lucky.
It's actually, we're gonna graph first, sorry, -3. It's gonna be right here, right here, right here, right here, right here, and the line is gonna keep on going. So that's the first part of the gang sign.
Oh, no, that's the.
Oh, the second part of the gang sign.
Oh, man, they're making a return.
You see, your phone blinking mode.
Yeah, you gotta stop that.
It's Yale. Colin needs to study. He needs to.
Okay, so now this is the 2L I was talking about. Okay, This is this way, this is this way. They can flip too when I have a negative sign. They can reflect. Okay, they can reflect. So those are the things I was talking about. So here's the things that you can understand this graph. Now, not only in this graph, there's asymptote. What is asymptote?
It's when they don't touch.
Okay, when you don't touch. How many of you guys have siblings? Oh wow, everybody has siblings. Okay, so your little sister probably come to you says, I'm not touching you, I'm not touching you, I'm not touching you, I'm not touching you, I'm not touching you,
Oh
right?
God.
Does that ever happen to you?
No, because he comes to me.
Yeah. It happened to you, so I'm not touching you. I'm keep on pointing a finger out. So I'll be not touching you. I'm not touching you. I'm not touching you. I'm not touching you. I'm not touching you. Right? Until like I'm getting so infinite close. Do you see my fingerprint?
No, if he wants to touch me, that's the thing.
No, yeah, they chased me around the house trying to touch me.
You too? Oh God.
Yeah.
Okay, so now then you say, oh, okay, well, this is the idea. This is asymptote. Asymptotes. I want to show you. And there's actually two asymptotes. One is right here.
And the other one's on the other side. Oh God, it's gonna rain.
And there's the asymptotes right here. So there's two asymptotes, and this is the asymptote. We're going to call it vertical asymptote. So vertical. That's vertical
When they don't
asymptote.
touch. You get a whole explanation about I'm not touching you.
So it's a vertical asymptote is x equal to 0, so which is the horizontal line, and there's a horizontal asymptote.
Don't worry, it gets worse.
Okay, there's a y equal to 0. And between those 2 points, you can find something. So now we're going to talk about domain and range. Domain is kind of difficult to tell. Domain is going to take this line. Well, this line is going to continue going this way. So it's actually negative infinity. Right? And they're going to go all the way here. Do you see all the lines touching, right? To this part, but it doesn't be 0. Good. So it's 0 here. Now there's the next one here.
It's positive.
Union 0 to infinity.
Union?
Yeah, that's two interval notation. So let's talk about this. So you go in here first, and then you jump over, and you go from here to here.
I don't
So the
understand.
asymptote makes the domain look like that.
It'd be like two fingers that are about to touch.
Yeah, it's about to touch, but they're not touching.
Reciprocal function looks like Messiah's game sign.
Yes, there you go. Alright, so some people say they don't get it. I'm just going over it again.
No, I
So
don't
make-
understand the union.
Oh, union just because there's two interval. You can say it's two things together.
Because it's not touching, so it's not.
Oh.
It's two different things.
So range is going to be the same thing. Okay? Is this even or odd?
Both.
Even?
Wait, let me
No.
see. Even.
Are they even? Is this side is equal to this side? No. But they do have an equal distance to this point though. Look at this point, this distance compared to this distance. Look at this distance compared to this distance. Are they the same? And look at the value. Look at the value. One
Yeah, it's
negative
odd.
1/3 and 1/3.
It's odd, yeah.
You look at this. You look at this. You look at this. This are functions.
Where? Asymptote.
Wait, it's odd. Wow.
It's our function.
Oh, wow.
Okay, so we're gonna cover the next two next time, but we're gonna talk about some other things. So those are the functions we did not cover,
Not those.
but we're gonna talk about all other things. We're gonna talk about transformations. Can you face the camera to this one?
Too far. There you go.
Tripod.
Okay, so we're going to talk about transformation now, along with the parent functions. So transformation. Quiz. What does x squared graph look like? Like a U, right? Like a parabola. So what if I say, hey, can you use it as a parent function? I say, can you graph this? What do you think it means? It means place the x into the x, right? So that's gonna be x plus 1 squared. Is that understandable?
Yeah.
I just place the x plus 1 into here and make sure it's a parenthesis. So what does the graph do?
Shift over.
Move to the left.
Left or right?
Right one.
Left and then move.
To the left.
Well,
Right, next one I got
since
zero
it's
on my
positive, huh?
To the right.
But we're gonna go to the left side. Left.
Left.
Thank
Good,
you.
because it's inside a parenthesis, right? So this is my original graph. This is my original. I have all the dots memorized. I have all the dots memorized like this. This is my original graph, and this is my original graph. So, okay. So now it's moving right one. So it's gonna go moving left one here. So it's gonna be new dots here. It's 0, 0. 1, 1, 2, 4, so it's gonna be here. Does that make sense? And -1 is gonna be here. This one's gonna be here, so the graph's gonna be like this. It's moving right, so this one's gonna be x plus 1 squared. This one is the x squared. Can the camera see me or no?
See good enough.
So what do you think this graph look like? So this is the parent function. Okay, this is the parent function.
Looks like a V.
What do you think this graph look like?
To the right one.
But to the right.
And down to. Because I was, so it moved to the right, yeah. And down
To the right,
One.
Yeah.
1, and then down
Two.
2. So basically that's what the graph do, because this one is actually absolute value x minus 1, right?
Yeah.
Minus 2. Does that make sense? I just plug in the x and plug in this outside is plugging outside here. So what does the graph do? So this is the original graph, right?
They move to the left, right?
Look, which one's moving? The vertex, your chin. That's why I say you had to look at your chin. Your chin's moving. It's moving what?
Left. Right.
Right 1 unit,
Oh, yeah. Oh, yeah.
right? Up 2 units. So this one is right here. This is my.
Wouldn't it go down to?
Oh, sorry, down 2. You're right. So move it right 1 and down 2. So according to coordinate, I have to follow the coordinates. I have to follow the coordinates. Does that make sense?
Boy.
Right 1, down 2. What does this graph look like?
It's more
Or like a
to the
half a
left, but
quarter
down.
football.
Quarter football, good. With a 0, 0, right? So let's look at it. It's gonna be look like this: 1, 1, and a 4, 2, and the graph's gonna be like this. But what if I say I want to graph this one? F of x minus 1 negative plus 2. What does that mean?
You gotta flip.
Move to the right, move to the right.
All right,
To the
1.
right.
No, you flip it first.
You flip first.
Multiply by -1.
Multiply by -1, so you're gonna flip. It's called reflection to the x
And
directions.
then up to.
And then up to. So what happened? So this point right here, right?
0 plus 1.
So this point here, we're gonna take this point, moving
The right one.
right 1.
Flip it.
And then the graph is gonna go in, instead of this way, it's gonna go in this way, right? But I'm not gonna sketch it, I'm gonna go like this. But it's gonna go up 2 units. So it'll be 1, 2. So it's gonna be like this. Now, remember that coordinate is what? X and Y is gonna be 0, 0, so this part is 0, 0. If it's a 1, it's gonna be 1, but we're gonna reflect it, so it's gonna be right here. So it's gonna be 1 here, get 1 here, and it's gonna graph, it's gonna go like all the way to 1, 2, 3, 4. So the graph's gonna be like this. How much time I have?
Not enough time.
Huh?
1 minute.
1 minute. So here's the homework that I want you guys to think about.
We just got.
Yeah.
For you guys don't have homework, but you guys have to do this. F of x equal to square root of x minus 4 plus 2, and then when x is less than x is less than -4, x is greater than -4. And the next function is negative x minus 1 plus 2, minus 2, sorry, minus 2. And when x is between 0 So I'm gonna ask you to start from next week. We're gonna do that in class, but you're gonna have a piecewise function look like this with a transformation. So I'm gonna sketch it really quick. Can you guys follow me really quick?
Yeah.
So this is a football graph going how many units to the?
Four to the left.
Okay, so I'm gonna sketch the graph really quickly.
To the right?
1, 2, 3, 4, right? And then go up 2, right? 1, 2. So this is my anchor point. It's gonna go up like this.
Isn't it supposed to go to the right?
It's
It's
Yeah,
negative.
go to the right.
oh, sorry, this is +4. This is
Oh.
yeah.
Okay, whatever.
Okay. Now this one's moving right 1 unit. Are we okay here?
Yeah.
Yeah.
And it's gonna be going down 2 units, so it's gonna be right here. And the thing is gonna be inverted. 1, 2, 3. So it's gonna be here. Are we okay here? Now last part, x minus 5 is a parabola, right? This is a square, this is a parabola.
Okay.
Parabola is moving 5 units. 1, 2, 3, 4, 5. And then going which way? 1 up, right? And the coordinates 1, 1, or -1, -1. And this one's gonna be all the way to 4. So 4 is gonna be right here. And this is an open circle. Okay, so this is the graph here. You can take a picture of this before you go.
Yeah, I'll go later.
What?
You want us to end it?
Yeah.